partial fractions by using this method called convenient values. So we just got done learning how to do it by doing linear equations. Sorry, my own camera sometimes is not too bright. Get it to work here, hopefully. And but today, right now, we're going to talk about is these convenient values. Give it a shot. Give it a chance. You might like it. To be honest, it's a lot easier than linear equations, solving by linear equations, but it doesn't always necessarily work. But here we go. If you remember correctly, we actually just did this problem barely with the solving system, solving it with a system of equations. The very first thing you would need to do to get your partial fractions over here, if you remember correctly, the very first thing you needed to do was to split this down the middle, factor this out, so you got x squared times x plus 2, and then over here you factored out a negative 1, gave you x plus 2, so then you got x plus 2 times x squared minus 1, which this is a difference of squares, which then says, oh, it's really x plus 2 times x plus 1 times x minus 1, which these are all three distinct linear factors, hence why they have the three fractions over here with each of those linear factors represented, x plus 2, x plus 1, x minus 1, the a, b, and c. Remember, it's just a, b, and c when they are linear. The next step, if you remember correctly, was to solve like we would a normal rational, where we multiplied by our denominator, which is going to be x plus 2, x plus 1, and x minus 1. So we're dividing here by x plus 2. That takes care of this x plus 2. Remember, we only need to do it twice if they appear in the same denominator twice. X plus 1 here, here, and there, so we're good. X minus 1 is here and there, so we're good. And remember, this is like all over 1. So when I distribute it in, the hope is that at some point in time you'll take note that when you distribute in here, the x plus 2 will simplify, giving you c times x plus 1 times x minus 1, which is what they got right here. Then when you distribute into here, the x plus 1s would simplify to 1, giving you b times x plus 2 times x minus 1, which is what they got right there. When you bring it to a, the x minus 1s would simplify, giving you a times x plus 2 times x plus 1, which is what they got right there. And then as you bring it over here to this side, the x plus 2, the x plus 1, and the x minus 1 would all simplify, leaving you with just 5x plus 7. Okay? Now, if you remember correctly, when we did it with a system of equations, the first thing we did then now is we distributed out the x plus 1 times x plus 2, and we started going that route. Well, there's another way. Instead of doing it that way, which I agree here is definitely tedious process, we can use what are called convenient values. These convenient values come from when what values of x would make one of these things become 0 and therefore cancel out. So in this case, we could say, well, what if we let x equal -1? Because if x was -1, then this would become 0, and 0 times anything is 0, so this would cancel. So we go ahead and say, let's let x equal -1 and see what happens. Well, by putting it in here, we get 5 times -1 plus 7 equals a times -1 plus 1 times -1 plus 2. So -1 plus 1 is 0. 0 times 1 is 0 times 8. So that just cancels. Plus b times -1 minus 1 times -1 plus 2. -1 minus 1 is -2. So this is a -2. -1 plus 2 is 1. So -2 times 1 times b would just be -2b plus c times -1 minus 1 times -1 plus 1. -1 minus 1 is -2. Negative plus 1 is 0. 0 times -2 is 0 times c is 0. That's going to cancel. That gives us 5 times -1, which is -5, plus 7, which is 2. Divide through the -2. and we get b equals -1. B equals -1. Well, that's very, very convenient to find b quickly that way. So we can come right back up in here, and we can say that this part of the equation is really plus -1 over x plus 1. If you want to check back to your notes, that's exactly what we had. B was -1. At this point in time, maybe instead of letting x equal -1, what if we let x equal -2? Because if I plug -2 in here, I still get 0 out, which is kind of a good thing. So let's try that. So if I let x equal -2, what happens? Well, I get 5 times -2 plus 7 equals a times -2 plus 1 times -2 plus 2, which -2 plus 2 is 0, -2 plus 1 is -1, 0 times -1 is 0 times a is 0, so that cancels. We then get plus b times -2 minus 1 times -2 plus 2. -2 minus 1 is -3, but -2 plus 2 is 0. 0 times -3 is 0, times b is 0, that cancels. Plus c times -2 minus 1 times -2 plus 1. -2 minus 1 is -3. -2 plus 1 is -1. -1 times -3 is 3. Times c is 3c. And 5 times -2 is -10. -10 plus 7 is -3. Divide by 3, we get c equals -1. So now we know what c is. C is -1, so that gives us plus -1 over x plus 2. Again, if you remember correctly, we did get c is -1. Doing it our other way by the system of equations. The last thing, last thing we have in let x equal, so we let x equal -2, that made that 0. We let x equal -1, made that 0. The only thing we have in let x equal is 1 here, and that'll make that 0. So yeah, that's great. So let's let x equal 1. So I'm going to try to do that right here if you're okay with that. So I'm going to let x equal 1. What's that going to give us? Well, it's going to give us 5 times 1 plus 7 equals, okay, we get a times 1 plus 1 times 1 plus 2. 1 plus 1 is 2. 1 plus 2 is 3. 3 times 2 is 6. That gives us 6a plus b times 1 minus 1. Does it really matter what this is? The answer is no, because 1 minus 1 is 0. 0 times anything is going to cancel. Plus c times 1 minus 1. Does it matter what this is? The answer is no, because 1 minus 1 is 0. 0 times anything is 0. That's going to cancel, so we just get 6a equals 5 times 1 is 5 plus 7 is 12. Divide by 6, and we get a equals 2, which that means right back up here, a equals 2, so that gives us 2 over the x minus 1, and that's equal to this thing right here, which was the 5x plus 7 over x cubed plus 2x squared minus x minus 2, which is exactly what we got when we did it earlier. Convenient values, a lot simpler, a lot easier to do. Let's go ahead and take a look at a practice problem, and I'll show you why we can't necessarily always use convenient values. So here it is. Here's our practice problem. It says find the partial fraction decomposition of the function. The very first step we have to do is factor the denominator. So remember, draw a line down the middle. Factor out an x squared. That's going to give us x plus 1. Here, factor out a 4. It's going to give us x plus 1. These are the same. So when they factor out, that gives us x plus 1 times x squared plus 4. X plus 1 is a linear factor, so my partial fractions is going to have an x plus 1 there. And that's an a because it is linear, because it's a 1 right there. X squared plus 4, this is quadratic. And this is not x plus 4 squared, which would be a linear squared or repeated linear. This is quadratic because it's x squared plus 4. So that means I'm going to have another one here that's x squared plus 4, which if you remember correctly, since it is quadratic here, we have to have bx plus c. And you might say, where did the b and the c come from? Remember, this goes a, b, c, d, and then it goes on, okay? So there it is. There's our partial fraction. We just split this up into partial fractions. Second step now is to multiply by our LCD, which means x plus 1 has got to be there. And x squared plus 4 has got to be there. And it's going to come here, here, and there. So as it comes here, notice the x squared plus 4's will simplify, giving us bx plus c times x plus 1. Okay? As I bring it here, the x plus 1's will simplify, giving us a times x squared plus 4. Okay? That's going to equal, as I bring it here, the x plus 1 simplifies, the x squared plus 4 simplifies, so that's going to equal 5x squared plus 3x plus 13. Now, I would say, hey, let's try convenient values. If I let x be -1, this whole thing becomes 0, which means this whole thing becomes 0, cancels out, so I'm going to do that. I'm going to let x be -1. If that's true, then over on this side, so as I let x be -1, I get on the left side 5 times -1 squared plus 3 times -1 plus 13 equals a times -1 squared plus 4 plus bx plus c. Well, b actually, we said let x be -1. So it's b times -1 plus c times -1 plus 1, which is going to be 0. 0 times anything cancels, so that all cancels. -1 squared is 1. 1 plus 4 is 5. That gives me 5a equals -1 squared is 1. 5 times 1 is 5. Plus 3 times -1 is -3 plus 13. 5 plus -3 is 2. 2 plus 13 is 15. Divide by 5, and we get a equals 3. So we now know a. Okay, so right down here, I'm just going to write 3 over x plus 1 plus, we don't know this bx plus c part, but we do know that this is x squared plus 4, and that's going to equal this whole guy right here. The 5x squared plus 3x plus 13 over x cubed plus x squared plus 4x plus 4. So we're close. We just need to get this part right here. Unfortunately, x squared plus 4, the only thing I can plug into x here to make the 0 are imaginary numbers, and we don't want imaginary numbers down here. So the only other option now is to go to solving with a system of equations. So remember, at this point in time right here, we distribute in the a. That gives us ax squared plus 4a. We distribute these guys in. It's going to give us bx squared plus bx plus cx plus c, and that's all equal to 5x squared plus 3x plus 13. Okay? So now we get our x squareds together. So that's ax squared plus bx squared. We get our ones with x's together, bx plus cx, and we get our ones without x's together, 4a plus c. So we can factor out the x squared, so that would give us a plus b times x squared. We can factor out the x, that gives us b plus c times x, and then we just have the 4a and the c. That all equals 5x squared plus 3x plus 13. So remember, whatever's in front of the x squared's got to be equal to what's in front of the x squared here. So we could say that a plus b equals 5. Whatever's in front of the x has got to be what's ever equaled in front of the x over here. So b plus c equals 3. And then this part here would have to equal 13. 4a plus c equals 13. So we need to find b and c. This equation right up top here is already set. We're now going to go to system of equations, and we're going to do that Gaussian elimination. We're going to get this into a triangular matrix. So I need to, these two are already good to go. We just need to get this bottom one solved for c. So we need to eliminate the a. So what I'm going to do first is I'm going to take -4. Scoot up just a little bit here. I'm going to take -4 times equation 1. Remember, this is equation 1. And I'm going to add that to equation 3. Remember, this is equation 3. That's going to replace equation 3. So I get -4a minus 4b, because -4 times b is -4b, equals -20. And now I have 4a plus c equals 13. I'm going to add those together. These will cancel. Gives me -4b plus c equals -7. Okay? This is now my new equation 3. Now I need to get rid of that b. So if I multiplied equation 2, remember this is equation 2. So remember, if I take 4 times equation 2 and then add it to my new equation 3, that's going to replace equation 3, and that'll get rid of the b, which is what I want. So I get 4 times b, which is 4b, plus 4 times c equals 12. And I add that to -4b plus c equals -7. I add those together. These will cancel. 4c plus 1c is 5c. That equals 5. We can quickly, easily solve for c by dividing by 5, or we would say that we would take 1/5 times our new equation 3. That's going to become equation 3. So that's going to give us c equals 1. So we do know c equals 1 now. So right up here, right up here, we now know a is 3. We wrote it right here. We now know c. Okay, we found it right here. C equals 1. So I'm going to put that right here, plus c, not c, plus 1. Now the last thing I need to do is just find b. Well, if I back substitute right here, I take c, which is 1, and I back substitute right in here, I get b plus 1 equals 3. So if I subtract 1, I get b equals 2. So right here I get 2x plus 1 over x squared plus 4. And that, my friends, is the solution. Again, is it tough? You bet. Is it impossible? No way. You guys can do this, okay? All right. Have a good one. Good luck. Bye.